Hi all, I hope everyone is doing great today. In this video, we would be going through the ucce call flow. There are many call flow models in ucce, but today we would be looking at comprehensive call flow. A comprehensive call flow refers to a detailed and structured representation, or it can be viewed as a diagram that outlines the sequence of steps and interactions involved in handling a call within the ucce environment. This call flow model helps you to understand how call is flowing through various ucce components. It includes call routing, call identification, self-service options, media handling, call treatment, call transfer, and many more. In ucce, comprehensive call flow is type 10. Other call flow models like standalone is a type 3 call flow model. It is type 10 because CVP serves as both switch and VRU leg. Call flow can be divided into four parts: switch leg, VRU leg, IVR treatment, agent leg. Let us see all four call legs one by one. This diagram block shows the switch leg. Call comes from the service provider, as you can see here. The call comes from the service provider and then it hits to the voice gateway or the SBC. The SBC or the ingress gateway has the dial pair configured to receive the call. For matching a dial pair, we can configure the CPURI or the incoming call number or the answer address, or else the port should match from which the call is coming. If nothing is matching, then the dial pair 0 is chose to let the call inside. Once the call comes through the ingress gateway, then the call goes out using the outbound dial pair. The ingress and egress can be in the same router, or else there can be a separate router for the ingress and the egress. Suppose a caller is dialing a 10-digit number. That can be a toll-free number or a DID number. Once the call leaves from the voice gateway or the SBC, it is taken by the CVP call server. CVP has 5 servers: CVP VXML server, CVP call server, reporting server, operation console, and the media server. The call eventually comes to the CVP call server, and in the CVP call server we have SIP subsystem, ICM subsystem, and IVR subsystem. In the latest version of ucce, IVR subsystem is the part of the VXML server. The SIP subsystem, once it receives the call, it looks at the SIP information and then leads the call to the ICM subsystem. The ICM subsystem will check the DNS length. DNS length. DNS length is nothing but the called number that the caller is dialing. The contact is dialing a 10-digit number. Maybe it is like 1800555324. So the 10-digit number comes and hits to the voice gateway, and the same number is relayed to the CVP call server, and then it is going to the ICM subsystem. ICM subsystem looks at the DNS length configuration that is in the ICM subsystem configuration of CVP call server. DNS length, if it is less than or equal to the DNS that is actually coming, then it is treated as a new call. Suppose the DNS length is configured is 10, but the call that is coming is having 14 digits, then the call is considered as an existing call. Since the call is coming with 10 digits, if it is less than 10 also, it is considered as a new call. Then the ICM subsystem sends the call to the VRU PG through a protocol called as GED125. And from the VRUPG to the ICM, it is the DMP protocol that leads the call to the ICM. As you know, ICM has router plus logger plus PG. In the ICM, the call will be landing to the dial number, and this dial number is configured in the AW. In the AW, there is a configuration manager where this dial number would be configured. Then the dial number is associated with the call type. The call type is used for contact categorization. For example, if the same number is coming in a different time zone, so then the call will be routed to a US agent or the US script. The person calling in Indian time, the call comes to the same dial number, but the call type, depending on the area code, or sorry, the country code, the call will be categorized and will be led to the uh, India script. So that is how we can use the call type. And the one more benefit of using call type is reporting. Once the call is selects the call type, then it leads to the scheduled script. Let us see the scheduled script and other configurations that we just talked about so that we get a fair idea of the switch leg. So you're looking at the operation console server where we will do the configuration for the CVP call server. As you can see, we need to go navigate to the CVP call server and then click on the call server that is configured, and we can see there is ICM subsystem, SIP subsystem and the IVR subsystem. Let me click on the ICM subsystem. Here we can see the maximum length of the DNIS. The caller who dials the DNIS or the called number, so it should be of 10 digits, and the maximum length of the DNIS is also 10, and then it consider it as a existing call, the new call, and then the call is going to the ICM. Let us see the configuration in the ICM that it takes for the call to be admitted. We need to log into the AW and then the configuration manager, tools, list tools, and here we can see the dial number. Retrieve, and here the dial number should match. Here the dial number should match. Dial number configuration should match with the DNIS that is coming. Just remember the default label that is configured over here. Once it matches the dial number, then the dial number will be having a call type. We can associate call type here, or else we can associate the call type directly in the script call type manager. Call type can be configured in the same configuration manager in the list tools. You can see here, this is the call type list. Once it matches the dial number, it has the associated call type, and then that call type has the script, and the script starts executing. Once you open the script, the start node is there by default. Then we need to add other nodes or the other blocks as per our requirement. So my requirement is to play the media, that is play the prompt, and then send the call to the queue. So if that is my requirement, then these are the blocks that I would take to configure. So as you can see, I have put some set variable blocks here. So basically these set variable nodes are taking some information from the ICM to the CVP. In normal context, the variables in programming is something that holds the value. Same analogy is applied here where some variables are configured, and these variables has some information that will be carried from the ICM to the CVP. These variables I have configured in the configuration manager. These variables are also called as ECC variables that we need to configure in the configuration manager. So these are the configured variables that I have, the ECC variables. These variables are by default and the user variables I have created for this call flow. These variables include input type, media library and the media server. It gives the information about the media server and the media library where the prompt is stored and the input type if it is a DTMF or text to speech. Let us go back to the call flow here. The set variables has the information about the media server prompt location and the input type that is DTMF. Then we have a node called send to VRU node. So this is a switch node or the translation node where it translates the call, it sends the call back to the CVP server from where it had come. Wherever we find in whichever block we are seeing this cross mark and the right mark, the call will go back or call will be sent back to the application like the CVP or any other application, third party applications. Send to VRU node, we no need to configure much here. There is no much configuration that needs to be done. Here, the send to VRU node will send the call back to the CVP from where it had come. So how does it come to know which CVP server it has come or where it should go? While going, it will carry two information, that is label and the correlation ID. Along with these variables that are defined, the call goes back with the label and the correlation ID. This is the switch leg where the call is coming from the cube. Invite is sent to the CVP call server. SIP information captures the SIP subsystem captures the SIP information, then leads to the ICM subsystem. Then the new call message goes to the VRU PG and a route request goes to the router, and then the script will invoke. Let us go ahead and see the next part of the call. Now the call has executed the script and it has reached to the send to VRU node. Send to VRU node is sending the call back to the CVP call server. While going back, it is taking the label and the correlation ID. If you remember, in the dial number configuration, I showed you about the default label. So it can take the default label that is configured in the dial number, that is 7777 10 times 7, plus the correlation ID, that is 1001. It can be anything. This is basically used for keeping the transaction. How exactly, we will come to know in the next step. This correlation ID is configured in the miscellaneous tool. Let me show you the configuration. It is configured in the miscellaneous tools, system information. So here we have the minimum correlation ID and the maximum correlation ID. Every contact or the call that is coming to the ICM, so that it will have a correlation ID. If a call comes, it will take 1000. The next call comes, it takes 1001. So this is how it assigns the correlation ID. And now the call is going back to the VRU PG, and then from the VRU PG it goes to the ICM subsystem. ICM subsystem checks if the call that is coming is a micro app or a number. So in this case it's a number because it's carrying a label and the correlation ID. If it is a micro app, the call will be given to the IVR subsystem. Since it's a number, the call will be given to the SIP subsystem. SIP subsystem, we would have configured the SIP static routes something like this, where I say if a call is coming from 7 followed by any number, that's a wildcard, which means any number followed by 7, it should go to the VXML gateway, and the VXML gateway IP is 192.168.1.10. With this static route, the call will be given to the VXML gateway. The function of the VXML gateway or the VVB is to browse the document, the VXML document that is given by the IVR subsystem or the VXML server. It just reads the document and does things as instructed by the VXML gateway or the IVR subsystem. For receiving the call to the VXML gateway, we need to configure a dial pair, incoming dial pair. The VXML gateway can be same as the ingress-egress gateway, or else it can be a dedicated VXML gateway. For admitting the call into the VXML gateway, we have an inbound dial pair and it matches an incoming call number, that is, in our case, that is 7T. That is 7 followed by any digits up to 32 digits. In the dial pair, if you see, there is this service bootstrap that is configured, and this service bootstrap is stored in flash, and this service bootstrap invokes bootstrap.tcl. And also it invokes bootstrap.vxml. Bootstrap.tcl does two things. Bootstrap.tcl, first it will check from which CVP server the call is coming. The second thing that it will check is the origination of the call. The call is originating from here. So the VXML gateway creates an audio path from the VXML gateway to the origination point. And then the bootstrap.vxml will send a request to the IVR subsystem, and then the IVR subsystem forwards the call to the ICM subsystem. Again, the ICM subsystem checks the DNS length. Let us see how the call goes from here to the ICM in the next slide. So as you can see here, the call is going with the connect message, then temporary connect goes to the CVP call server, and then the SIP invite is going to the VVB through the static route that is configured in the SIP subsystem. And then after doing few things, the call is coming back with a new call is coming back and then going to the IVR subsystem, and then the IVR subsystem will send the call to the ICM. Let's see how it happens. I will show you the configuration so that you get a fair idea of the static route configuration. If we go to the call server and then go to the SIP tab, so we can see here there is 7 and a wildcard followed by the IP address. How exactly it is given is 8, for example 8, then a wildcard, that is anything after 8, it should match, and it should go to a VXML server, for example 10.1.1. So this is how we add, this is how we add the static routes in the CVP server. After creating the audio path from the VXML gateway to the from the VXML gateway to the origination point of the call, The bootstrap.vxml sends a request to the IVR subsystem and it is forwarded to the ICM subsystem, and ICM subsystem, as you know, it checks the DNS length. We already have seen the configuration that is required in the ICM subsystem, that is the DNS length. Since the label and correlation ID is coming, in our case it is like 14 digits. Since the configured value DNS length is 10 but the number that is coming is 14, which is greater than 10, it treats this session as an existing call, this call as an existing call. And the call is forwarded to the VRUPG, and before going to the VRUPG, the label and correlation ID is separated, and only the correlation ID is forwarded to the ICM. And now the ICM looks at the correlation ID and it realizes that it's an existing transaction. And the control of the call is in the script. And in the script, particularly, it is with the send to VRU node. Since it was successful to create the audio path and come back, it connects to the success route of the VRU node. As you can see here, the set variables are taken to the CVP, then the call has come back as a successful call, then it goes from the success node, the call goes to the run external script. Run external script node, it is used to play the media, get speech, or play data, play digits, capture menu. So it has the information about the micro apps. So micro app is basically a IVR function, and this micro app is used to do is a set of instruction to the VXML gateway. The ICM does not know what is a micro app, but we would be mentioning it in our scripting and also in the configuration. Run external script. Let me show you the example configuration. Go to properties, and here you can see there is a micro app called as play media. Similarly, there are 6 micro apps, default micro apps, and with the micro app followed by a script name is there, that is the prompt name is there, that is welcome.wave. This prompt is not stored in ICM, it is stored in the media server of CVP media server. And ICM does not know what is this play media. It just we have just configured it here, and this information it will pass to the relevant parties, and then those relevant parties knows what to do it. The relevant parties can be VXML server or the IVR subsystem. Let us see how the IVR subsystem makes use of this play media micro app. As I have already told, micro app is a IVR function. It has a set of instructions to the VXML gateway. And how exactly this is configured? We need to go to the list tools, then network VRU script list, and here we can define the VRU script name, that is play media, followed by the welcome.wave prompt name. As you can see here, in the script, the run external node has 2 connections, that is the cross mark and the right mark. That means the call is going back now. Now when the call is going back, it is taking the micro app as well. When the call goes back, it takes the micro app with it and goes to the VRUPG, and then the VRUPG relays this to the ICM subsystem. Again, the ICM subsystem checks the call and sees whether it is having a micro app or a number. This time it is a number. And we know that micro app is an IVR function that has a set of instructions to the IVR subsystem. Then the ICM subsystem sends the call to the IVR subsystem. IVR subsystem pulls the play media micro apps template. It will be having the 6 default templates, that is play media, get speech, capture, menu, play data, play digits, and get data. And IVR subsystem pulls the play media template and it will start filling the information. So what information it will fill? It will fill the information that we passed about the variables, that is the media server IP address, media path address, or the path, media server address, and then it will fill the input type. We can also specify local and other variables as well. It depends upon our requirement on how we want to build the script. With this information, it also includes the prompt that has to be played, and then it creates a VXML document, and this VXML document will be sent to the VXML gateway. As I've already told you, the VXML gateway browses the document that is sent by the IVR subsystem or the VXML server. So then the VXML gateway looks into the VXML document, and in the VXML document it is instructed to play the welcome.wave file. Now the VXML gateway checks the welcome.wave file in its cache. Suppose if it is not there in its cache, then the VXML server will contact to the media server, and that media server IP is in the VXML document. Once it is able to reach the media server, then it will look into the path where this file is stored, and then it will retrieve the file, and then it will add in its cache, and then it will start dumping the audio in the path that it created in the previous step. The caller hears the welcome prompt when it dumps the audio in the audio path that it created in its previous step. Once this task is done, there is no more information in the VXML document. Then the VXML gateway will send a request to the IVR subsystem. The IVR subsystem will forward this request to the ICM subsystem. And ICM subsystem, as usual, will check the DNIS length. Again, the DNIS length is 14 now with the label and the correlation ID. The ICM subsystem separates the label and the correlation ID and then forwards the call to the ICM. ICM will check the correlation ID and it will come to know about the transaction, and it will look for the control of the call, and the control of the call is in the script, that is in the run external script. Let me show you the configuration. Let me show you the location of the media server. So this is my media server, and if you want to locate the file of the media server, so this is the path. So in this path I am having the file. The VXML gateway will query this server and locate the file and load this file in its cache. We can have a third-party application as a media server, or else we can use the same Windows machine and we can use it as a media server as well. Since it's a big call flow, I will recap the things that we have just discussed. The call came from outside and hit to the ingress gateway. It matches a dial pair. Then the call goes to the CVP call server using an outbound dial pair. and it goes to the SIP subsystem. SIP subsystem forwards the call to the ICM subsystem, and then the ICM subsystem sends the call to the ICM. Before sending the call to the ICM, it checks something called as DNS length. If the DNS length is less than the configured value, then it treats it as a new call and then the call goes to the ICM. Once it goes to the ICM, it invokes the script, and in the script we have some set variables. Along with that, we have send to VRU node, which means the call has to go back from where it has come. Call has come from the CVP server, so call will go back to the CVP server. Along with that, it will take label plus correlation ID. ICM checks if the call that is coming is having a micro app or a call number. So in our case, it's a number, so the call will be given to the SIP subsystem. SIP subsystem has a static route configured, then the call will be pointing to the VXML gateway. VXML gateway has a dial pair, inbound dial pair to receive the call. Along with the inbound dial pair configuration, it has a bootstrap service configured which will invoke bootstrap.tcl and bootstrap.vxml. The bootstrap.tcl will check from which CVP server call has come, and also it will check the origination of the call and creates an audio path. The bootstrap.vxml will send a request back to the IVR subsystem, and then it will be forwarded to the ICM subsystem. The ICM subsystem will check for the DNS length. This time it is more than the configured value, then the call will be given to the ICM. While the call is given to the ICM, it will separate the label and the correlation ID, and the correlation, because of the correlation ID, ICM comes to know about the existing transaction, and then it will check where is the control of the call, and that resides in the script. And the send to VRU node is a successful connection, so it will proceed with the next node. The next node is run to external script. Run external script has a micro app and a prompt file name. Along with this information, the call will go back to the ICM subsystem. ICM subsystem will check the call that is coming is a micro app or a number. In our case, it's a micro app, so the call will be going to the IVR subsystem. IVR subsystem will pull the play media micro app. Since the micro app that we defined in the ICM is a play media, so it will pull the play media micro app and it will start filling the information. It will fill the media server IP that it got from the set variables, and then it will fill the media path and the input type, and also it will fill the prompt name. With all this information, it creates a VXML document and hands over the VXML document to the VXML gateway. VXML gateway, as its function, it reads the document that is provided by the IVR subsystem. So in the document, it is mentioned to play the welcome.wave prompt. If the welcome.wave prompt is in the cache, then it will play. If it is not there, it will get from the media server and it will play the prompt. Once it is done, the call will be sent to the IVR subsystem and then to the ICM subsystem. The ICM subsystem again checks the DNS length and sends the correlation ID to the ICM. Then the ICM checks the control of the call and it is at the run external node. Now since the call has come back without any error, it will route through the success node to the next node of the call. Let's see in the script what is the next node of the call. As you can see, the next node in the script is skill group. Since the call came back successfully, it routes the call through the success node to the skill group. Skill group has agents, and router knows which agent is available, is in not ready state, wrap up state. So basically, router knows exactly how many agents are available in the skill group. In the next node, we have the skill group or Q2 skill group. In our case, it is skill group, and in the skill group, we have few agents, and the router knows exactly who is available to take the call, who is the best person to serve the contact. How the router knows about it is router is getting the live feed from the PG. PG gives the real-time information to the router, and PG knows which agent is available, who is in wrap-up state and not ready state. So PG provides the the extension of the agent who is available. Assume that 1234 is the extension that is available, and that information the router fetches. And then the call will go back to the CVP call server with the agent extension. The ICM subsystem will check if it is a micro app or a number. This time it is a number, so the call will be forwarded to the SIP subsystem. As you have already seen, the SIP subsystem, we can configure the static routes, and this time I will configure it as if a call comes as 1, 2 and anything, then the call has to go to the CUCM, that is 192.168.1.97. Then the call has a SIP trunk to the CUCM, so then it will route to the CUCM. The CM service is managing the telephony system of the agent. So then the call will start ringing on the telephony system. Then how the finish will also ring, so that is through the CTI gateway. This information will be relayed at the same time from the PG to the CG server, that is the CTI gateway, and then the CTI gateway is connected to the Finis server, and Finis is managing the Finis agents, Finis desktop. That is how the phone and the Finis application or the Finis desktop will ring simultaneously. Once the call is disconnected, the script will end normally. There is an end node for the script and the script will be ended. So this is the normal call flow of ucce or the ICM call flow. So there are variations in this call flow depending on the customer requirement. We can introduce external VXML to send the call, external VXML node in the script to send the call directly to the VXML server. If you see here, the call didn't go to the VXML server, it went to the media server for fetching the prompt. That is because we have used Play Media micro app. Get Speech is the only micro app that is used to go to the VXML server, or else we can use an external VXML node in the script to send the call directly to the VXML server. In the VXML server also we can do the scripting part using the call studio. And also we can make use of the third-party applications and create the scripts and put it into the VXML server as a application. So this is the basic comprehensive call flow that is commonly used. I hope this session is informative for you. Have a nice day ahead. Thank you.